Hello everybody, this is lecture 3 for chapter 1.5 in the text. It covers material for weeks 5 and 6. The next lecture is for weeks 7 and 8, and that will cover chapter 3 in the text on fallacies. The next new module opens soon. Look for it in Canvas. Let's review material thus far. Look at pages 22 through 24 in the Hurley course text on conditional statements. Conditionals are statements comprised of two clauses, an antecedent condition and a consequent condition. They say that whenever the antecedent is true, then the consequent is also true. Conditionals never say that the antecedent makes or causes the consequent to be true, but they do imply that the consequent is true whenever the antecedent is also true. This is why they are also called implications. Implication is a logical relation between claims which sometimes enables us to draw true conclusions from all true premises, so long as the argument form is valid, an idea which is formally introduced in chapter 1.3 of the text. Recall from the last discussion that bad arguments can be comprised of implications and yet have a valid form. For instance, here's an argument. If a creature is a spider, then it has 10 legs. If it has 10 legs, then it has wings. If it has wings, then it can fly. If it can fly, then it's venomous. Therefore, if a creature is a spider, then it is venomous. Now, this conclusion follows from these premises. Logically, necessarily, given the form, and only if every assumption is true. But in fact, each assumption is not true. In the discussion, we talked about this. You should see that if all the premises were true, then the conclusion would be true necessarily. That is, it couldn't be false. It's a connected chain of reasoning. But in this case, all of the premises are actually false. Even if the conclusion happens to be true, which it isn't here, the argument doesn't justify it. It fails the truth condition requirement by having at least one demonstrably false premise. When I say demonstrably false, I mean we are able to show that it's false. I gave counterexamples to each conditional in the discussion, so again, review that discussion. Let's review how to satisfy the logic condition and the truth condition. These are very important skills we need to test arguments. We look at the logic of an argument first, and then we look at whether or not its assumptions are true. Failing one of these essential criteria means the argument's bad. For logical analysis, we want to know how much the form supports the conclusion. Determine the strength with which the premises support the conclusion. In this case, this example, the conclusion is probable. So it's inductive strong. It is raining. When it rains, outside games are usually canceled. Therefore, the outside game is canceled. I mean, this isn't necessarily true. We don't criticize an inductive argument, a strong argument, for not being deductive. No one's saying it's necessarily true. Conclusion, the best way to read the conclusion is that it's probably true in light of the evidence. In general, when it rains, we cancel outside games. However, we can imagine playing a game in light rain or under a shelter. A truth value analysis, what's that? You have to ask whether the alleged facts are actual or probable. In this case, determine if the information in the premises is accurate, correct, true. In the argument on this slide, if any of the premises are inaccurate or weak, then the argument becomes inductive weak. It is raining. Is this a true or false statement? I mean, if it's not raining, then the argument's going to fail. When it rains, outside games are usually canceled. If this isn't usually true, like, 90% of the time, I mean, if you say 60%, that's not usually what usually means. You can push it if you like, but it's going to be as likely as in the past if we are following the past as precedent. People are struggling with this on quizzes. Let me say a little bit more. How do you identify deductive and inductive arguments? Look for keywords. They may or may not be there. And sometimes you have to just guess whether the conclusion is meant to be necessarily true or probably true. In a deductive argument, you'll see words like necessarily, certainly, definitely. In an inductive argument, you'll see something like probably, likely, unlikely, plausible. Next, look at the logical strength of an argument. For a deductive argument, the conclusion is necessarily true. It can't possibly be false when all the assumptions are true. Well, what do you do if one or two of the assumptions is false? Then all bets are off. The conclusion could be true, could be false. That argument can't justify it. Conclusion could be accidentally true. Conclusion could be about a completely different subject than the premises address. It could be true, but that argument wouldn't support it. In the case of induction, conclusions are only probably true. So there are these two kinds of arguments we focus on, deductive versus inductive. Deductive arguments typically occur in logic, mathematics, geometry, definitions, formal arguments. Inductive arguments often will draw comparisons, make analogies. Legal arguments, moral arguments, arguments about what we should or should not do. Statistical arguments, causal, scientific reasoning. Such arguments are typically inductive, although of course scientific arguments, statistical arguments also feature deductive mathematical reasoning. See later chapters 9, 10, and 13 in the Hurley text. We'll get back to this. So how do conclusions of deductive and inductive arguments follow from premises? This is really important. This goes to how we test arguments, test their logic. A deductive argument is one in which it is claimed or presumed that the conclusion follows necessarily from the premises. Another way of saying this is that true premises make it impossible for the conclusion to be false. In short, the conclusion of a deductive argument contains, if you like, or summarizes information in the assumptions. To the extent that they are true, so is the conclusion. An inductive argument is one in which it is claimed or presumed that the premises make the conclusion probable, likely, in proportion to how much evidence you have for it. True premises make it improbable then for the conclusion to be false. Is the following argument deductive or inductive in form, and why? Most first-year college students have part-time jobs. Sue is a first-year college student. Thus, Sue has a part-time job. I'm going to call this inductive. If the premises are true, then it's probably true that Sue has a part-time job. Not necessarily true. However, the conclusion can be false, since we are told only that most first-year college students have part-time jobs. Compare this to a similar but different deductive argument form. All first-year college students have part-time jobs. Sue is a first-year college student. Thus, Sue has a part-time job. Notice here that if the premises are true, if they are true, there is no escaping that conclusion. It's necessarily true. Sue has a part-time job. So, the truth of the premises guarantees the truth of the conclusion. This is not the case with the inductive version. Further, the original argument is, I'm going to call it inductive strong, only if the most means at least greater than 50%. You always have to check the language. People can use words however they wish. We want to be understood. We want to make sure we're communicating clearly what we mean. Sometimes we have to check with people what they mean by the term most. I'm guessing, from the way lots of people use it, that we mean something like greater than 50%. However, some people might want 75 or 85, 90%. So it's on you to check what their presumption is. For inductive arguments, we're going to call the good arguments cogent arguments. It's a fancy way of saying that they have all true premises and a form, which makes it very likely their conclusion is true when those premises are true. Inductive arguments, let's talk about their strength versus their truth. And here we're talking about logical form, logical strength, the strength of the connection, the relations between the premises and the conclusion, versus the truth of the assumptions, whether or not they're true, or likely true. Logical analysis tells us whether an inductive argument is strong or weak in form. A strong inductive argument has true premises that make it probable that the conclusion is true. So it's this combination of its form plus the true premises. You need both. A weak inductive argument is one where true premises still make it improbable that the conclusion is true. So it's weak because of its form, the strength, or rather the lack of the strength of the connection between the assumptions. For instance, on insufficient evidence, a person might draw a conclusion that doesn't follow even probably because there is not enough evidence. Small sample size, unrepresentative sample, for instance, from which one may be drawing a conclusion. It's important to realize that strong does not mean good. Here, strength only refers to logical form. It's one of the required criteria for a good argument. Let's talk about the truth versus the strength of inductive arguments. Let's talk about truth. A truth analysis tells us whether an inductive argument is cogent or uncogent. A cogent inductive argument is one where the argument is strong and the premises are true. An uncogent one is one where the argument is weak or has at least one false premise. So there's two ways an argument is not cogent. Bad form, it's weak, doesn't have sufficient strength, or contains a false assumption, relies upon a false one. Now, the only good inductive arguments are those that are cogent. All the rest are bad arguments. Again, I'm talking about inductive arguments. Deductive arguments, that's different. Deductive arguments have to be sound. Valid plus all true premises. I mean, unless, with respect to induction, unless a strong argument is also good, it is regarded as bad because it supports inadequately whatever conclusion one intends to prove. Compare these two inductive arguments for strength. Each has the same conclusion, but only argument A is good. An opaque jar contains exactly 100 marbles. There are 99 blue marbles in the jar. There is one red marble. The marble picked is blue, right? So the next marble we choose, we're going to predict it's going to be blue. Most likely we'll get a blue marble because 99 out of 100 of them are blue. No guarantee we will, because obviously we could, low probability, we could choose one that's red. That's a strong argument. Weak one. Argument B. An opaque jar contains exactly 100 marbles. Okay, same assumption from before. There are 99 blue marbles in the jar. There is one red marble in the jar. Conclusion. Probably the marble picked next is red. Yeah, that's unlikely, right? I mean, you have a 1 in 100 chance of getting a red marble. I mean, of course, there's a possibility. There's even a small probability. But it's unlikely that that claim is true, given that distribution of blue versus red marbles. Inductive strong versus inductive weak. Here's an argument. Most politicians are liars. Mariana is a liar. Thus, she is a politician. This is weak. Even if both premises are true, they do not support adequately the probable truth of the conclusion. Most politicians could be liars. Sure, Mariana could be a liar. And she could just be anybody who is not a politician. There are lots of liars who aren't politicians. Compare this similar sounding but different argument. If you like, it's a better argument. Most politicians are liars. Mariana is a politician. Thus, she is a liar. Now, this is a different argument because it has a different conclusion. Here we may conclude it's likely she's a liar because she's a politician and, well, most of them are liars. No guarantee. This is a strong inductive argument because it is improbable that she is not a liar, since she is a politician and most of them are liars. This argument is cogent if all of its premises are in fact true, given this logical form, given the strength of the relation between the assumptions and the conclusion. Okay, now let's take a look at section 1.5 in the Hurley text on argument forms and proving invalidity. This is a useful but difficult technique. If you master this, you will have a powerful tool for refuting arguments on the basis of logic alone. Brief review. On the handout, I refer to Critical Thinking Skill 7, or how to tell whether an argument form is valid. You always have to ask yourself the following with respect to any argument. Can the conclusion be false even if all of the assumptions are actually true? That is, even if all the evidence someone gives you, all the facts a person presumes are true, is it still possible that their conclusion is wrong, is false? If it is, then the argument has bad logical form. You don't even have to check the facts. You can reject an argument based on bad form alone. This goes for deductive and inductive arguments. Now, in this chapter, we're only going to focus on deductive arguments, how we test their form for validity. Again, a deductive argument is valid if and only if it is impossible for the conclusion to be false when all of its assumptions are true. One way to show this is to demonstrate that an argument is invalid. How do you do this? You produce an example of its form, or a substitution instance of its form, its pattern of reasoning, where all the premises are true and the conclusion is false. However, this method can't be used to show that an argument form is valid. For that, we construct a truth table or a truth tree. We use more formal logical methods. That is beyond this course. If you're interested in that, take Philosophy 60, Intermediate Logic. Again, to be clear, just because you can't prove an argument is invalid by this method doesn't mean it's valid. All we can do with this method, still very useful, is prove an argument form is invalid. We might fail to show an argument's form is invalid, and it might still be invalid. It's also true we might fail to show an argument form is invalid and it's valid. Realize this is only a test for invalidity, not valid. With respect to deductive arguments, again, validity versus truth, we're going to focus on validity. Logical analysis tells us whether a deductive argument is valid in form. That is, does it guarantee the truth of the conclusion when all premises are true? Or we can see it's invalid in form because it doesn't guarantee that the conclusion is true. Invalid form means unreliable. Doesn't mean always false conclusion. In fact, you can have an argument with all false claims, including a false conclusion. That's valid in form. The point is, valid argument forms guarantee the truth of the conclusion when all the premises are true. Invalid forms just don't. You might have an argument with invalid form that has a true conclusion. The point here is that you can't trust that argument because its reasons don't logically make necessary the conclusion. Again, for valid deductive arguments, an argument with all true premises is one given that form for which it's impossible the conclusion is false. And an invalid deductive argument is one where even if the premises are true, it's still possible for that conclusion to be false. Truth analysis tells us whether a deductive argument is sound or unsound. And we're going to put this to one side, but I remind you what that is. A sound argument, that's one that's valid and the premises are true. An unsound argument is one which is invalid and at least one premise is false. So we're going to be looking here for valid arguments, and valid arguments with all true premises are called sound. So here is an extract of an image from the text which outlines how this counterexample method test using substitution instances or examples of the logical form of an argument may be used to prove that the form is not valid, not truth-preserving, not one we get the guarantee from that says the conclusion is actually true. In other words, this is one where we aren't guaranteed the conclusion is true, even if the assumptions are true. So let's take a close, careful look at the logical form of a deductively valid argument. And what's new here, we've been talking about valid arguments. What's new here is I'm going to use arbitrary letters as symbols for the parts of arguments. It's easier to extract the form, the pattern, and then look at that pattern and ask ourselves whether that pattern can give us a false conclusion still, even though the assumptions are true. Okay, take a look at this. It really helps to separate logical form from truth analysis. Again, we're focusing on logical form. Here's an argument. All beagles are dogs. All dogs are mammals. And so we may conclude necessarily all beagles are mammals. That's a valid argument. And here's the pattern. All B are D. All D are M. All B are M. Perhaps you recognize this valid form. It's hypothetical syllogism. And what you need to know about this is any substitutions in this exact form will also be valid. And by substitution, I mean you can replace those terms with any other subject. And you should see that there's no way you can escape this relation between the first claim's antecedent condition and the second claim's consequent condition. The counterexample method can prove an argument is invalid, but it can never prove an argument is valid. You recall from our discussions, a counterexample demonstrates, by example, illustrates that a claim is false, that a conditional, for instance, is false whenever its antecedent condition is true, but its consequent is false, because all conditionals, hypotheticals, implications, all conditionals say, whenever the first part's true, so is the second part. And if you have an example of where the first part's true, but the second part isn't, that proves the conditional's false. Can't use it, can't trust it. Any argument that relies upon it is going to be bad. The counterexample method isolates the form of a deductive argument and then constructs a substitution instance of that form with all true premises, but a false conclusion. This is really important. You always have to start with a false conclusion and then work backwards. False conclusion from all true premises. If you can do that, if you accomplish that, if you are able to come up with an example with a false conclusion, an example of that form, where you get a false conclusion from all true premises, there's something wrong. That argument is invalid. Can't be trusted. It allows you to conclude something false from everything true. You should recall that any argument that allows a false conclusion to follow from all true premises is invalid. That's its definition. It's unreliable. It fails the logic condition test. So the form of an argument determines whether or not it is invalid. Its content, its assumptions, whether its assumptions are true or false, don't. Again, this is a test for form. This is a test for whether the argument satisfies the logic condition. A substitution instance that has all true premises and a false conclusion is called a counterexample, which we may use to show that an argument is invalid. There's two things happening here. I've talked about counterexamples to claims, conditionals for instance. Counterexamples show that a particular claim is false. Counterexamples to the form of an argument show that a conclusion may be false from all true premises. And that's what this method focuses on, and I have to say a lot more about it. I should tell you that you need to work through. It would be unwise not to work through every single example in section 1.5 where the author goes through several arguments. Look at the arguments in blue, where he talks about them and shows you how to apply the method of counterexample. Then you need to go further. Do every one of the exercises at the end of chapter 1.5. At the end of that chapter, each of those arguments in the exercises is actually invalid, and you should be able to demonstrate to yourself that you understand why. That is, you can think of examples where the conclusions are false, but the assumptions are true. Counterexamples expose false claims or invalid forms. We're going to focus on the invalid forms of arguments here. A counterexample to a statement, for instance, shows the claim, if it rains, my car gets wet, is false when we describe a case where, okay, it rained, but my car's in the garage, so my car doesn't get wet. So when you say, if it rains, my car gets wet, or if R then W is true, you're wrong, because R could be true. It could rain, and yet my car doesn't get wet. Now focus on the counterexample to an argument form, which is what's shown in the box here in this slide. I'll illustrate that even all true premises don't make the conclusion necessarily true. That is, the argument is invalid. See, this is something a lot of people don't realize. They could have all the evidence in the world and their statements of what they observe could be true. And yet their conclusion might still not follow because there's an error. There's not this necessary relation between the assumptions and the conclusion. In this case, let's look at the argument symbolized, where we've got this abstract pattern first, and then we'll look at its instance. All M are H, all W are H, therefore all M are W. The reason we use this test is that it isn't easy, and we shouldn't trust ourselves when we think we can just see whether an argument's valid or not. You never can do that. You got to do some kind of test. You have to imagine whether the conclusion could be false and the assumptions true. And this is a method for doing that. Of course, another way to recognize the pattern is valid is for it to be exactly like a pattern you know, like hypothetical syllogism, modus ponens, modus tollens, etc. Okay, so here is an instance, an example where we fill out the details of the abstract argument, where the letters are terms standing for M's or H's or W's. Here we go. All men are humans. Okay, that's true. All women are humans. That's true as well. And so can't I conclude all men are women? Hold on, something went wrong. Yes, something went wrong. Now, without going into too much detail, you don't have to say what exactly is wrong, or you don't have to say what the name of this mistake is. You have to see that, I don't know what you'll call this. I'm just going to call it invalid, but there's no way that conclusion is necessarily true. In fact, it's false, and yet all the assumptions are true. So this is basically demonstrating that any argument with the form all M are H, all W are H, and therefore all M are W kind of sort of looks valid, but it isn't. It's demonstrating that it never is. Now check your understanding by looking at this. Now, check your understanding by looking at this counterexample pattern. Is this argument form valid or invalid? To test it, extract the form and substitute terms. No CRB, no CRS, no BRS. Okay, so this is going to be invalid. Let me show you why. My example, my counterexample shows that from true premises you can get a false conclusion with this logical form. For instance, no crocodiles are boas. No crocodiles are snakes. Conclusion, no boas are snakes. Hold on, that's wrong. We want this. We want to show an argument's invalid, and the way to do this is that we have to realize a conclusion could be false and all the assumptions are true. So do that. So make an example where the conclusion is false and all the assumptions are true. How did I do this? I thought about I wanted to say something false in the conclusion. So no boas are snakes. So I got the idea of boas, which actually are snakes, and the idea of snakes. And then I used boas and snakes in the assumptions to show the alleged relations don't produce a necessarily true conclusion. In fact, they allow a false one. I want to get through a few examples here. Definitely, again, work on the ones in the text, but here are a few I think are particularly illustrative. Use the counterexample method to show an argument is invalid. First, step one, state the argument precisely, charitably. That is, say it in such a way that we're fair to the person that gives the argument. We don't want to overinterpret what they say. We don't want to avoid something that they probably assume simply because they don't say it. Look at number 9 on page 63 in the exercises in the text at the end of chapter 1.5. Here is the argument presented in standard form, where I list the premises and then the conclusion as clearly as possible. This is the first step in exposing the form, creating a substitution instance of that form, presenting a counterexample, and showing there's a problem, that the argument pattern is invalid. So the argument's kind of complicated. It says all persons who assist others in suicide are people guilty of murder. Second assumption, some people who assist others in suicide are individuals motivated by compassion. Accordingly, some individuals motivated by compassion are not persons guilty of murder. You need to realize that you got to get the conclusion right. And this one accordingly helped me out. Plus, I looked at the other claims and I noticed that the weakest claim, the one I'm going to call the conclusion, the one which needs the most support, is the one it looks like the other claims are supporting. So I've got the conclusion, put that on the bottom, list the premises, number them for reference. Next step, extract the form, the logical pattern, using arbitrary letters to stand for terms. And by arbitrary letters, I mean you don't need to use letters from the beginning of any of the particular words. You just want to use letters you can manipulate consistently throughout the argument that preserve the exact relations between antecedents, consequence, and the claims in the argument. So don't confuse the first letters of words in the original argument with the terms you want to use in your counterexample. You could use the first letters of particular words. I often do that, but I can confuse myself by using those letters. I often confine myself to examples of things that begin with that first letter. So it's a foolish limit I put on myself. So don't be connected to the letter you use. However, whatever letter you use in your substitution, use it the same throughout the argument. So here's the pattern. All ARM. I'm saying A stands for assisters, people who assist others in suicide. And M is going to stand for people guilty of murder. So the letters are somewhat suggestive of what's going on in the argument itself. But the claims are so complex. I mean, what does murder mean? What does it mean to assist others? What does it mean to commit suicide? What do you mean by compassion? What does guilt mean? That's all confusing. Let's extract the terms, substitute in simpler letters to stand for the relations, then check it. I'm going to use A again in the second claim because I'm talking about people who assist others in suicides, and C is going to be people motivated by compassion, individuals motivated by compassion. Conclusion, some C are not M. Some compassionate people are not people guilty of murder. Not done yet. We've just stated the argument. We've extracted the pattern. Next step, substitute another simpler instance of the exact same form and provide a new key to your terms. Your key says, hey, this letter means this letter means this, etc. And what I've done here is I've extracted the form, all ARM, some ARC, some C are not M. On the left, you can see A stands for animals. I just choose animals. I think they're easier to think about. For me, I know a bit more about animals than pretty much anything else. And a lot of us do, so you want to choose something that you are familiar with that you also can presume others are, so you can persuade them that their argument pattern is fallacious, error-prone, unreliable, invalid. Here it is now after I've substituted in for the A and the M and the C other things. All animals are things with nervous systems. Okay, that's true. That's the thing about animals. Some animals are dogs, right? Okay, some animals are dogs. Third claim, conclusion. Some dogs don't have nervous systems. Okay, what are we doing? The conclusion's got to be false. But that conclusion doesn't sound right. Good, it's not true. In fact, it needs to be false. Notice, you have a false conclusion that apparently follows necessarily from ultra assumptions. That's bad. That's invalid. Step 4, we analyze or evaluate the argument. What happened? This argument has the exact same form as the more complex sounding original argument in the exercise. Since its form is invalid, and we showed this by our own example, because it permits a false conclusion to follow from all true premises. So too is the form of the original argument. Again, your counterexample proves that any argument with this same bad form is invalid. And this is where people get a little stuck. I mean, the first big problem people have is reconstructing arguments, getting exactly the right conclusion. Sometimes we confuse conclusions and premises. That's bad. The argument will not be adequately represented. We're going to make a mistake. But once we restate the argument clearly, get the right conclusion, express the relations accurately, we have got to check whether that conclusion necessarily follows if all the assumptions are true. How do you check it? Well, gee, if all the assumptions are also true, could I get a false conclusion? If so, the argument's bad because it's unreliable. Doesn't guarantee the conclusion is true. So the key to understanding the counterexample test for invalidity of form is the following. When you produce an example of the exact same logical form of the argument you wish to test with all true premises and a false conclusion, then you have proven that the form is not valid. You have proven that the form is invalid. How did you do this? You showed you could get a false conclusion from all true premises. Again, an argument that is invalid is bad. Be careful. An argument can still be invalid even if you fail to produce a counterexample. So this counterexample test does not tell you whether an argument is valid, only if it is invalid. I hesitate to say this, but this test is powerful. It is logically reliable. The limits on the test are the limits on our imaginations. See, critical thinking is not merely negative. In fact, I'd like to say it's not even mostly negative. It's actually being creative about thinking how the things we say, the things people believe, the arguments people give are mistaken. This is what I mean when I say this counterexample test for invalidity is not foolproof. Sometimes we are in a hurry. Sometimes we are foolish. We don't try hard enough. We let an argument pass. We think that from our failure to think of a counterexample to an argument, that must mean it's good. See, an argument's not good because we can't show it's wrong. It's good only if we can show it passes the logic condition test and the truth condition test. Okay, here is another example of an application of the counterexample method. Look at number 8 on page 63 in the text. Here is the argument in standard form. Some toxic dumps are sites that emit hazardous wastes. Some sites that emit hazardous wastes are undesirable places to live near. Thus, some toxic dumps are undesirable places to live near. Now, extract the exact form using letters that stand for terms. Again, don't confuse the first letters of words in the original argument with the terms you want to use in the counterexample. You may use them, but if you do, you are not confined to words or terms that start with those letters. You have to just use your terms consistently. So here's the pattern of reasoning. Let's look at the third claim first. Notice above I have some toxic dumps are undesirable places to live near. Now I used indicated words in the way the claims given were relating to each other to get the conclusion some toxic dumps are undesirable places to live near. That needs to be false. I'm thinking, okay, here's what I mean by needs to be false. I'm wondering whether this argument is valid, and so I wonder whether the conclusion could be false and all the assumptions are true. So let's see if we can extract the pattern with a false conclusion. So let's presume some toxic dumps are undesirable places to live near is false. What would it look like if that was false, but all the reasons given were true? Some TRE, some ERU, therefore some TRU. Now look at this. This looks like hypothetical syllogism, but it really isn't because that's a valid form. That only works with all TRE, all ERU, therefore all TRU, or if something's a T, then it's an E. If something's an E, then it's a U. So we may conclude if something's a T, then it's a U. We got the word some going on here. Some means at least one. At least one is not enough. So it's not hypothetical syllogism, which would be valid. It's something different. Now, substitute another simpler instance of the exact same form. Again, some TRE, some ERU, some TRU. I'm going to talk about animals again. So I'm thinking, okay, I want a false conclusion, some TRU, So let's see, real easy, some dogs are cats. Some dogs are cats. Yeah, that's wrong. Good, because we need that to be a false claim because we want to see if that false claim can follow from all true claims, right? So some dogs are cats need to be false. There's no dispute about this. You want your examples to be, counterexamples need to be really clear. Most everybody in the room, reasonable people will accept, yeah, that's an example of something which is false, a claim which is false. Okay, so now let's fill in the details here. How do I get some dogs are cats as a conclusion using the same pattern in the argument above? So we plug in for dogs, we plug in for T dogs and we plug in for E mammals. Some dogs are mammals. Yeah, that's true. Some mammals are cats. Yeah, that's right. So can't we conclude some dogs are cats? No, that's just wrong. So something went wrong. Forget about it. The argument pattern's bad. The conclusion's false, even if all the assumptions are true. Don't trust this pattern. You've just proven it's invalid in form. And that's the evaluation. The argument has the exact same form as a more complex sounding original argument. It's the same pattern. We're doing the logic test. Since its form is invalid, because it permits a false conclusion to follow from all true premises, so too is the form of the original argument. Again, your counterexample proves any argument with the same bad form is invalid. How does it do it? It shows you can get a clearly false conclusion from all true assumptions. So that's it. That's the counterexample method in 4 steps. State the argument precisely, extract the logical form, substitute another instance of the exact same form with all true premises and a false conclusion, where if you succeed in producing an example where the conclusion is false and the assumptions are all true, then you prove the form is invalid. If you don't succeed, your results are inconclusive. Could be valid, could be invalid. You just haven't shown that it's invalid. Doesn't mean it's valid. Continue trying to test it, or try another test, a more formal test. And finally, you evaluate this. You analyze the argument. You evaluate whether your counterexample has shown the argument is invalid by showing that its logical form is invalid. This method only tests whether an argument satisfies a logic condition, to be clear. It doesn't test the truth condition. Another example. I'll get through this one a little more briskly. Again, you can scrub back and forth. You should go through all of these examples in addition to all of the examples in the text. And definitely work on every exercise at the end of the chapter. There are maybe a couple dozen exercises. You should do them all. State the argument. Look at number 3 on page 64 in the text. Here it is in standard form. If human rights are recognized, then civilization flourishes. If equality prevails, then civilization flourishes. Thus, if human rights are recognized, then equality prevails. Now, as I look at this, I can't tell whether it's valid or invalid. No, really, when I'm being serious about analyzing an argument, in most cases, I have to write it down. I have to sketch the argument out. I have to reconstruct it, unpack it, look at the form. In fact, I advocate you check the form before checking the facts. I got to tell you, it's actually easier to check the form than the facts. You can save yourself a lot of time. You don't have to dispute facts if you can just show the logical form is bad. Usually the way people work is you have to show them their pattern of reasoning is wrong. And most people don't appreciate this, by the way, so you have to choose your battles. And then you go in and check the facts, the alleged facts, the sources of the claims, the evidence, allegedly. I mean, I have no idea whether if human rights are recognized, then civilization flourishes. Certainly optimistic people think so, right? It's speculation to say this is the case. But hey, if it is true, and claim 2 is true, then hey, maybe human rights, if recognized, coincide with equality becoming dominant or prevailing in a society. I don't know. Let's take a look at the argument pattern first before we take it seriously and test its assumptions. Obviously, in this case, we're not going to get to test the assumptions because we're going to expose there's invalidity here. The argument isn't logically valid. So we extract the form. If R, then F. R is going to stand for human rights are recognized. F stands for civilization flourishes. E is going to stand for equality prevails, and F again already has been decided. We decided it stands for civilization flourishes. So conclusion is if R then F. You got to extract the form before you evaluate it. A lot of us get ahead of ourselves and start evaluating arguments. Even we evaluate the form prematurely. We make mistakes. Even those of us with lots of experience using logic, probably at least 2 or 3 times a week I make a mistake, jumping ahead and just sort of assuming an argument's pattern is valid or strong, and then I'm tangled up in disputes about facts, which I can't resolve. All the while, what I'm having trouble with, not realizing, is that I did not notice that the form can't be trusted and that I should walk away from that argument or ask a person for a better version of their argument. You got to extract the form. You can't just see that it's valid by looking at it. Next, substitute another simpler instance. And by simple, I mean, use those simple terms, concepts, like think about animals. Everybody likes animals. People are open to thinking about the relations between animals. Remember, we have to start with a false conclusion. So if you like, write that out, put that on your piece of paper where that's going to be at the bottom. You can put the numbers in there later. So we want if R then F to be false. Again, what makes that false? Remember we talked about what makes conditionals false. Conditionals are false always, whenever the antecedent condition is true, but the conclusion is false. See, that means you can't trust that claim. It's saying if R is true, then F is true. So you think of a case where R is true, but F is not true. So here's the example. You always give us a substitution key. Do this for yourself. R stands for snake, F stands for reptile, E stands for lizard. How did I get this? Well, what I did was I said, I want if R then F to be false, so I need a true R and a false F. So I'm thinking a snake, thinking about snakes and lizards, for example. So if something's a snake, then it's a lizard, right? No, that's false. Good. We want a false conclusion. We want a false claim. Snakes are not lizards. Lizards aren't snakes. Okay. I mean, obviously they're related. They're both reptiles. But the point here is that we want to say something clearly false. Now we say something using the exact same form. We can't confuse antecedents and conditions. Say something using the exact same form of the premises. That is, state 2 claims, 2 conditionals. In this case, we're trying to realize this pattern. State 2 conditionals where the claims are true. Already got a false conclusion. Now get a true set of assumptions based on my key here, my thoughts about snakes and reptiles and lizards. Here we go. Number 1, if a creature is a snake, it's a reptile. Let me think. Yes, that's true, right? Right? We want that. It's true. Another way to say this is that all snakes are reptiles. Okay, fine. If a creature is a lizard, then it's a reptile. So all lizards are reptiles. All lizards, yes. Even Godzilla, right? Okay, so we have a true first claim, true second claim, but false third claim. That's bad. This pattern can't be trusted to give us a true conclusion. The conclusion doesn't necessarily follow, and that's what we mean when we say a conclusion doesn't follow. It means it could be false even if all the assumptions are true. It's like saying, I would accept your conclusion if everything you said was true and that conclusion was true. But I don't accept your conclusion because I think it is false even though everything you say is true. And then the person you're arguing with is going to say, yeah, well, you got to show me. This is how you show them. This argument has the exact same form as the more complex sounding original argument. That's the goal. The form is invalid. It permits a false conclusion to follow from all true premises. Again, move back in the examples to show yourself you understand this. I want to mention some common errors when you attempt to prove invalidity. Seriously, review these. I still commit at least one of these a month, I guess, when I'm analyzing arguments seriously. Number 1, you state the wrong conclusion in your reconstruction. You still have to have that basic skill of recognizing accurately the conclusion from among the other statements, the assumptions, the premises. That's a learned skill. We're all going to make mistakes. If we make a mistake, we try again. Be careful not to choose or frame an inaccurate conclusion. We're often in a hurry and we confuse a premise with a conclusion. Number 2, big error we make. You state a non-false, that is, true conclusion. Because we're thinking we want good arguments and we're looking for true conclusions. Why are we talking about what's false? Well, in this case, we have to have a false conclusion that follows logically from all true assumptions to show that that pattern is unreliable, that pattern is invalid. So if you state a true conclusion in your counterexample, you've made a huge error. You are not demonstrating, you cannot demonstrate with that the argument pattern is invalid. If you're not stating your substitution with a false conclusion, you will fail to produce a counterexample. No way out of this. Number 3, you have one or more false premises in your counterexample. Now, we talked about this. The truth condition test requires showing a premise or two is false. But right now we're doing the first test, the logic condition test. So it doesn't matter whether any of the assumptions are true or false. We need them to be all true. Okay? The recipe for a counterexample requires that you show how we can get a false conclusion from all true premises. That's the definition of an invalid argument. Remember, what you're doing here is you want to prove that the form which you suspect is invalid. Really is invalid. Number 4, you failed to imagine a counterexample, so you conclude that the argument is valid or not invalid. Nevertheless, it could still be invalid, only you have not shown it, not yet. I bet if you do all of the exercises at the end of the chapter, chapter 1.5, you will have 1 or 2 or 3 of those that you cannot think of a counterexample to. That is, you cannot come up with a false conclusion from all true premises, even if you get creative, try to think of a substitution instance which shows it. Now I'm telling you, you can see from the instructions that all of the arguments are invalid. And what's going on there is you're being challenged to get creative about finding an example that proves it's invalid. So don't give up, take a break, walk away for a while, come back and try again. It's a puzzle. The goal is to show yourself you understand. The goal is to be able to apply the method. Failing to succeed at producing a counterexample to an actually recognized, designated, invalid pattern is actually a good reason to continue to try to show, because you know you don't have it yet, you don't understand it. So all of this in a nutshell is what I'm talking about when I say critical thinking skill 8 is how you show a deductive argument is invalid. At least this counterexample method shows this. You show it's not valid by showing how a conclusion can be true when all assumptions false. Reveal that pattern. Then consider counterexamples to the form itself. You construct a substitution instance. Your substituted instance, your example, uses all true premises and a false conclusion. This is called the counterexample method. You use it to test whether the form is valid or invalid. Again, how you do it in a nutshell is you state the argument, extract the form, substitute terms, and evaluate. Again, it works because every substitution instance of a valid form is itself a valid argument. Now, technically, it's not the case that every substitution instance of an invalid form is an invalid argument. We won't be concerned about that technicality now here. What we need to know is that we are able to produce an example of an invalid form in order to show the pattern can't be trusted. Here is a summary then of everything thus far, the skills described, illustrated thus far. There are 2 ways arguments go bad. An argument is bad if it fails the logic condition check, that is, if it's possible or probable that its conclusion is false when all of its premises are true. For instance, Jane got straight A's in high school, so Jane will probably get straight A's in college. Now, you should see that that's an inductive argument right there, and that in fact, you can use the counterexample test roughly with inductive arguments as well. So here, Jane got straight A's in high school, suppose that's true. Can we conclude then she'll get straight A's in college? Not really, because college and high school are different. The other way arguments go bad is that an argument fails the reality check. I call it the reality check. I mean the truth condition test. That is, at least one of its assumptions is false or dubious, and you are able to show this by a counterexample to that statement. Jack completed all of the quizzes because Jack passed the course. So what I'm doing is I'm concluding Jack completed all the quizzes since Jack passed the course. But wait a minute, it's possible, isn't it, that Jack passes the course. That's true. It's true Jack passes the course, and yet he doesn't complete all the quizzes. In fact, this course is one of those. I'll get to this. Critical thinking skill 9, then, is how you tell whether an argument is good. Big summary here, an argument is good if and only if it is either sound, deductive, valid, sound, all true premises, or cogent, inductive, strong, all true, probably true premises. You've got to restate it in a charitable way, a fair way. You've got to reconstruct its form so you can check it. You've got to clarify, then check the facts, check its assumptions. The argument's good only if its reconstruction passes both tests, the logic check and the fact check. Only assumptions are true or false. Arguments are not true or false. Similarly, arguments are strong or weak, or valid or invalid. Claims are not strong or weak, valid or invalid. When we evaluate an argument with unstated premises, things that are not said, we have to restate them perhaps, or insert them in the argument, or state them out loud. Often arguments imply lots of things we take for granted, lots of things we're entitled to presume. We can't say everything we assume in an argument, although we can expose a common assumption as false by the counterexample test, or by citing evidence, counter-evidence, to a claim presumed. And that's the subject of this week's discussion. And finally, this is it, critical skill 10, how to prove an argument is bad. And you can do it. You can actually prove it. In fact, what you're going to do is give an argument that shows an argument is bad. You can show its form is illogical because it's either not truth-preserving, deductively valid, where the truth of the premises guarantees the truth of the conclusion. We could show it's not truth-generating, where we mean inductive strong. A truth-generating argument is one which reveals some new or further or projected truth. Call this the form test, the logic condition check. Summarizing here, we could also show, if we want to prove an argument is bad, we could show next that its content, or at least one of its assumptions, is false, incredible, dubious. That's the truth condition test. Good arguments, by comparison, are less vulnerable to these problems than are bad arguments. But really, all arguments are vulnerable to criticism, right? They're only as good as their weakest assumptions. They are only as strong as the form. This is a test for soundness in deductive arguments, or a test for cogency in inductive arguments. So to be perfectly clear, an argument is bad, technical concept in logic, an argument is bad if it fails to justify its conclusion. If and only if it fails either the logic check or the reality check. One error, one failure, it's over. In other words, an argument is bad if it is neither sound nor cogent. Such arguments fail, either the logic check or the reality check. This is how to think about it. An argument's bad if it's not good. There's no in between. So, which are the bad arguments? I'm using a diagram from the text here. I think this is in 1.4, section 1.4 of the text. Where are the bad arguments? Well, these are going to be, among the deductive arguments, these are going to be those which are either invalid or unsound. For inductive arguments, it's going to be the weak arguments. All weak arguments are bad, or any uncogent argument is bad. And where uncogency is going to follow from the weakness of the logic in an inductive argument. So here's an example I'll leave for you to think about. Proof by the counterexample test that the following argument is invalid. No patrons of fast food restaurants are health food addicts. Consequently, no patrons of fast food restaurants are connoisseurs of fine desserts, since no connoisseurs of fine desserts are health food addicts. That's it for now. Work on the exercises in the text. I've said this over and over. Use the counterexample method to prove some argument forms are invalid. So do part 1, exercises 1 through 10, part 2, exercises 1 through 10. Do them all, really. Next up, we're going to talk about fallacies, where fallacies are defects in arguments or named common errors in reasoning. There are formal and informal fallacies. And I'll open that module soon, and we'll start talking about fallacies. You do want to see the summary of fallacies on pages 195 to 196 in the text for the official list of those I will focus on in this course. These are a subset of many known fallacies. Be advised that a fallacy often goes by different names, since these reasoning mistakes are ancient and have been described by many thinkers independently of one another. That's the end of Lecture 3 for Chapter 1.5. Talk to you next time.